So here we have a driven damped pendulum analog. I sometimes call it a shake and washboard. The up and down shake is like the pendulum. You have the bottom and the top of the pendulum swing. And then the applied torque in the driven pendulum is supplied by the back and forth motion of that frame. Okay, there's a pseudo force. Okay. So as you see, one of the problems we have here is that it falls off the edge. So another possibility for doing this is you could have a tilted circle, have it go around the circle, has a low part and a high part, and then the circle is rotated. Whoa, okay, come on, make it over the top, yeah. There it goes, yay. Yeah, we can put different balls on here to get different frictions. Since gravity gives a force proportional to the mass of that marble, and the pseudo force from the acceleration gives a force proportional to the marble, any mass marble on there will have the same forces except for the friction. Oh, there. Hold on. So I'll put this other one here. This guy here will have, I think it's more friction. And you notice that the motion doesn't go over the top as often with this one. I think I could be wrong here, but yeah. Sometimes it stays there with very little motion, and then after a while it gets bigger. Or maybe it's just settling down to the attractor that's a very small amplitude back and forth. And there's one thing that's kind of hard to see. Is it going farther up one side than the other? That's one of the predictions that we have, is that that you have, at small driving amplitude, you have a symmetric oscillation back and forth, and as the motion gets bigger, the stable solution is a little bit higher on one side than the other, or it could be higher on the other side than the one. It's hopefully symmetric if it's perfectly level. There's no right-left asymmetry here. So let's turn this up a bit and see what happens. So if I make the frequency higher, I also make the amplitude higher, because acceleration is A omega squared. If A is the distance it moves, and omega is the frequency of the motor. And let's put another marble. Let's try this one. Whoop, looks like it's going to go off the edge. Yeah. Whoops.